resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Have you ever heard this saying, "Kitabein bhi bolti hain"? And here we are. Hello friends, this is Shreyans Kothari and I welcome you all to the YouTube channel of Shant Academy. Friends, in this channel, what we generally do, we usually put the video solution of many books, various books published by Shant publication. Generally, we follow a simple pattern. What is that pattern? In that pattern, what we do is, we try to make you understand the whole concept, the basic concept behind the topic. We go chapter by chapter, and once the topic is clear, when the concept is clear, we'll do some of the questions from the book itself, and we do it for all the chapters in the book. And I tell you, you can see this chapter standalone as well. From the book, you just scan the QR code and here you are. The chapters can be seen standalone as well, because in this video, we have cleared the whole topic. And talking about this book, I tell you, this is the book for quantitative aptitude. This is the most comprehensive book available in the market in the country for quantitative aptitude. You name an exam, say for example UPSC exams, you tell banking exam, SSC exam, railways exam, defense exam, NDA, CDS, any exam, even campus recruitments, MBAs, all the exams are covered. This book is full of questions from previous year, mock questions, and a lot of questions. So you can see this as a whole question bank for quantitative aptitude and most researched book, most updated book for you all. So why wait? Here we go to the chapters. So here we are with the chapter number 1, the first chapter of the book, that is number system. Let's see what is number system. I have got the screenshot of the book so that I can make you understand what exactly this say. I don't think it will need much of the detailing because everything is clear, and the starting of this book is very much easier. See what it says. In Hindu Arabic system, we have 10 digits, like we know it very well, that 0 to 9 are the 10 digits, right? A number is denoted by a group of digits called numeral. Say for example, these are the digits and group of that these digits is known as a number. Now for denoting a numeral, we have a place value chart. Place value chart, you know it very well. Then from the right hand side of any number, you have ones, tens, hundreds, thousands, 10,000, lakh, 10 lakh, crore, 10 crore or something like that. So these numeral, say for example, this is 5, 2, 8, 6, 7, 9. So what you can say is 5 lakhs, 20,000, sorry 28,000, because 10,000 is 2 and 8 is this. So 28,679. It is written like that, 5,28,679. In the similar way you can do that. So I don't think that will be a big challenge for you because you know it very well. These are the numbers, and we generally in day-to-day life, what we do is deal with a lot of numbers. So these are the way you can denote them. In the similar way, this is the, say for example, a table. Table can be called as in the words like this, and we have some of the words and you can do in the tabular form. Say for example, the third one, 4,04,040. So we have 4 lakh, 4,040, something like that. And in general way, you can write that 404040. Is it like that? 40, 40 and 40. So this is the general denotion. So we are not very much worried about this. Let's move on to the next thing. Now this, what you call is a place value and a face value. What is that? See, the face value of a digit in a numeral, its own value. Face value is what exactly is looking like. Kaisa nazar aa raha hai, face usi ko kehte hain. So at whatever place it may be. So in the numeral 6, 8, 7, 2, the face value of 2 is 2, 7 is 7, 8 is 8. Whatever it is looking like. Say for example, if I say 7, 3, 4 and 9 for example. So this face value of 7 is 7, see 3 is 3, 4 is 4 and 9 and 9. So whatever it is looking like, it is known as face value. But there is a term called place value. What is that place value? Place value of one's digit is one's digit into 1, tens digit, 10 digit into 10. Say for example, if I say 7, 3, 2. So the face value of this 2 is 2, this 3 is 3 and 7 is 3. 7 is 7. So this is the face value. Then what is place value? This 2 into 1, that is 2. This 3 into 10, that is the place value of 3 is 30 and place value of 7 is 700. So ones, tens, hundreds, thousand, 10,000. In the similar way it goes. So the place value is the value of face value into the place it is on, right? So we have this face value and place value system. Now we come to the main part, important part. You should know all these terms. I'll let you know each and every term in detail, not to worry at all. We'll discuss all the things in the book, right? So here we go. We have various types of numbers. Say for example, natural numbers. So all the counting numbers starting from 1, 2, 3, 4, 5. All these numbers are known as natural number. And then we have whole number. So all the natural numbers with 0. So including 0, we have all the whole numbers. So it is like 1, 2, 3, 4 and all the natural numbers go on. And if we include 0, it will be whole number. So in whole number, we include 0 with all the natural numbers, right? Now we have integers. What is integer? All counting numbers 0 and negative of counting numbers are integers. Integers means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 and minus 1, 2, 3, 4, 5, 6, 7, 8. So whole numbers plus the all negative numbers. These are known as integer number. See, what I suggest is just take out a notebook or a register and try to write whatever I am saying. Because see, this video, if you consider like the other videos on YouTube, like entertainment, it will not work for you. Try to understand that this is a sort of lecture. A student is studying in a class and a teacher is telling each and everything. So if you are in a class, you must take your notes, right? Take down your notes. So what I suggest strictly is just bring out a notebook, register and write all the things what I am saying. These things obviously they are in the book, but I am suggesting, I am giving you some other things as well. I am giving you some extra things as well, so that you can script down, right? So let's move forward. So we have got positive integers 1, 2, 3, 4, 5. Then we have got negative integers minus 1, 2, 3, 4, 5. And all non-negative integers. Non-negative includes 0 because 0 is neither negative nor positive, or you can say positive. So all the non-negative integers as 0, 1, 2, 3, 4, right? Even numbers. So what is even number? You know it very well. You have heard of it a lot of time. 2, 4, 6, 8, 10. All these are even number. Starting from 0, we have 2, 4, 6, 8, 12. All these are even number. And what about odd numbers? 1, 3, 5, 7, 9, 10. So in this way, you know that every even number comes with addition of 2. So 2, 2 plus 2, 4, 4 plus 2, 8, 8 plus 2, right? In the similar way, we have odd numbers and that is also with the gap of 2. 1, 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9 in the same way. Then there are prime numbers. So धीरे धीरे level बढ़ता जा रहा है. See, natural number, whole number, ये सब सब समझ आता है. Now when you talk about prime number, what exactly prime number is? See, prime number, a counting number is called a prime number if it has exactly two factors, namely itself and 1. Now what is factor? Factor is basically a number divided by a number. So when you divide a number with something, that is known as its factor, right? So say for example, there are some numbers, say for example, when we talk about say 6, when we talk about 5. So tell me all the numbers from which this is fully divided. So it is divided by 1, fully divided by 2, divided by 3, divided by 6, no remainder left. So 6 is divided by 4 natural numbers without leaving a remainder, right? Now 5 is divided by 1 and 5. So any number who has just two factors, the number itself and 1, is known as prime. So obviously this is not prime, right? What is not prime, we will see ahead. What I told you is prime numbers are all counting numbers if it has exactly two factors, namely itself and the number. And we have all the prime numbers less than 100. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. All these numbers do not divide by anything else like leaving number itself and 1. Now we call what is composite number. Composite. This composite number is basically non-prime number. Non-prime numbers, all counting numbers which are not prime. Composite numbers. A composite number has more than two factors. One itself, the one and itself, and more than that. So always the composite number will have more than two factors. Now we call the what is perfect number. Perfect number. Perfect number is a number the sum of whose factors except the number itself is equal to the number. Sum of its factors, sum of its all the factors is equal to the number leaving the number itself, right? Say for example, we have 6. So the factors are 1, 2 and 3. So when you add 1, 2 and 3, it will go 6. Here it is. Say for example, 28. So 1, 2, 4, 7 and 14. When you add all of them, it will be 28. So these are known as perfect numbers. That's perfect. Let's move on to the next part. Let's see what does it say. It says we have co-prime number. Now what is co-prime number? Two numbers whose HCF is 1 are called as co-prime number. That means they are not at all related to each other. Their HCF, the highest common factor, they don't have any common factor other than 1. So for example, we have 2 and 3, we have 8 and 9. 8 has factors 4 and 2, 9 has factor 3 and 3. So that is 3. So basically 3 and 8, 9 and 8, they don't have any common factor other than 1. That is known as co-prime number. Twin primes. What is twin prime? Two prime numbers whose difference is 2 are known as twin primes. Prime numbers with difference of 2. Say for example 3 and 5, twin prime number. 5 and 7, twin prime number. 11 and 13, twin prime number. Rational number. Numbers which can be expressed in the form of P by Q, where P and Q are integers. P and Q are integers and Q is not equal to 0. Q cannot be 0. That is known as the denominator part. Anything which is under the bar is known as denominator. Anything which is above the bar, that is known as numerator. So this denominator cannot be 0 for sure, and this we call as rational number. Rational number is like 1 by 8 minus 8 by 11, because as I said, it can be any integer. So minus is also included, zeros are also included, but not as denominator. 0 is also included, as I told you. 6 is all. So you will say that, see for example this 6. How this 6 is a rational number? Because there is no Q, that is no denominator. So 6 can be written as 6 by 1. So 1 is integer, 6 is integer. This is a rational number, right? Irrational number. What is irrational number? Which cannot be expressed in decimal, would be non-terminating and non-repeating form, are called as irrational number. Say for example root 2. When you find out this root 2, it has a very long value. Decimal के बाद इतने सारे numbers, इतने सारे digits आते हैं कि we don't know much. So this is known as irrational number. Let's move on to the next part. What does it say? So we have some formula for you all. What are those formulas? See, all natural numbers are whole numbers. As I told you earlier, whole number includes 0 and all the natural numbers. All the whole numbers are not natural number. Obviously, 0 is not there, right? So 0 is a whole number which is not a natural number. Then we have something for you to understand. See, if you add two even numbers, the answer will always be even number. Even if you add two odd numbers, the answer will be even number. Because this odd number has 1 in it, this odd number has 1 in it, 1 and 1 is 2. So that will always be even number, right? When you add even number with odd number, it will be odd number. So because this is fully divided by 2, this obviously not. So when you add these two, it will be odd number. Even number minus even number will be even number, and odd number minus odd number will be even number only. But if you subtract odd number from even number, that will not be even number, that will be odd then. What next? When you subtract odd minus even, it will be odd only. When you multiply two even numbers, get even number. When you multiply two odd numbers, get odd number. Remember this. When you multiply two odd number, it will always be odd number. But when you multiply odd and even, it will become even, right? Eventually. The smallest prime number is obviously 2, because 1 cannot be a prime number because 1 is only 1. The only even prime number is 2, because 2 is the only even prime number. Every other number, yeah, you can say that any number more than 2, if it is even, obviously divisible by 2, so it cannot be a prime number. First odd prime number is 3, that you know, right? Let's move forward. We have something more here, right? What exactly it is? 1 is a unique number, neither prime nor composite. As I told you, 1 cannot be divided because 1 has only one factor, that is 1. And for prime, it must be 2 factors at least, right? The least composite number is 4. Least composite number. The composite number starts from 4, as it says. The least odd composite number is 9. So below 9, that is less than 9, all the odd numbers are prime numbers. Now, test of prime number. How to test a prime number very easily or very fast? Say for example, a big number comes, say for example 179. We don't know when 79 will be divided by something or not. So, how to calculate that? Let's move on to this part. A basic test is given. Generally, what is required? Say this number 137. Is this a prime number or not? Just do one thing. Just make it clear that which number is just bigger to 137 and a perfect square. We know that 144 is a perfect square. 144 is a perfect square. So, a number just bigger than 137 and a perfect square. You need to find that. So, its square root is 12. So, take out all the prime numbers which are less than 12. All the prime numbers which are less than 12. Say for example 2, 3, 5, 7 and 11. Just divide these by 137. If there is any factor from this 2, 3, 5, 7, 11 of 137, it will not be a prime number. Otherwise, it is prime number, because 137, you cannot wait till long कि शायद हो सकता है 19 से डिवाइड होता हो या शायद और किसी से होता हो. You don't need to wait. You just see one thing. एक ऐसा नंबर जो 137 से बड़ा है और एक परफेक्ट स्क्वायर है, उसका स्क्वायर रूट कीजिए. उससे छोटे जितने प्राइम नंबर है वो लिख दीजिए. उनको चेक कर लीजिए कि उनसे डिवाइड हो रहा है क्या. अगर नहीं हो रहा है, क्लियरली नन ऑफ देम डिविजिबल बाय 137, दैट मींस 137 इज अ प्राइम नंबर. बट 173 से बड़ा जो परफेक्ट स्क्वायर है दैट इज 196. सो 196 का स्क्वायर रूट है 14. नाउ 14 से वाले सारे नंबर लिख दो. None of them divides this 173. It is a prime number. So in this way you can do bit easier. You can find bit easier the prime number, right? Let's move on to the next part. Now these are the basic formulas. All the formulas must be written in your copy. Write them twice, thrice, 4 times, because all these formulas are easy. And in all the algebraic expression you can find them. So I'm not repeating this. You must read it, right? Here we move on. We move on to the next part, test of divisibility. So this test is very important. I'll tell you all the tests of divisibility, and you must write those in your notebook and in your mind also, because that is very important. Not for this chapter, for the upcoming chapters, all the chapters in the book. This part is also very important. So anything divisible by 2. Just check whether the last digit of the number 0, 2, 4, 6, 8. If it is there, it is divisible by 2. As it says 0, 2, 4, 6, 8. अगर last number, that is number on the ones place, इनमें से कोई आता है, आगे कितना भी लंबा नंबर लिख दो, it will for sure be divided by 2, right? Divisibility by 3. Now this is interesting concept, and I usually follow this concept in my mind. What? if the sum of digits is divisible by 3, if the sum of digits is divisible by 3, that means this number is divisible by 3. For example, this big number 6954221. What I'll do is, see, I know 6 is divisible, 9 is divisible. I know that 5 and 1 is divisible, 4 and 2 including. How did I do it very fast? See, if I add something to 6, it will be divisible. If I add something to 9, because 9 is divisible, when you add it to anything else, it will be divisible. 5 and 1 makes 6, so it is also divisible. 4 and 2, they make 6, again it is divisible. So the whole number is divisible by 3, because you need to do just one thing, add all the numbers. The add number will be 27. Now this number is divisible by 3. Sometimes the addition of the number, the addition of the digits will be a big number. Say for example, addition comes out to be 273. Now is 273 divisible by 3? Do the same thing again, repeat the process. 7 into 9 and 3, again divisible by 3. So this is divisible by 3, that means this is divisible by 3. That's it. Let's move on to the next divisibility. How to check divisibility by 9? So divisibility by 9 is the same process. You add all the digits. The sum of the digits must be divisible by 3. Same concept like 3. When you add all the numbers, if the number comes and that is divisible by 3 for 3 and 9 for 9. If it is divisible by 9, it will be the whole number, the big number will be divisible by 9. Let's move on to the next part. Now we have divisibility by 4. So what to do? Divisibility, a number will be divisible by 4 if the last two digits means the digits at the ones place and tens place, if they are divisible by 4, that means this number is divisible by 4. Say for example, this whole word, I just need to check whether 76 is divisible by 4 or not. So 76 we can do it easily, because 76 plus 4 is 80. So if adding 4 is divisible, then 76 is also divisible. If 76 is divisible, the whole number, the big number, will always be divisible by 4. What about 8? So when it was 2, we check the last number. When it was 4, we check the last two numbers. When it is 8, check the last 3 digits. If say for example 484 or 352, these 3 digit number are divisible by 8, then the whole number, whatever the number is divisible by 8. Keep in mind. Now divisibility by 10, I guess this is the easiest one. Need not tell you. If there is the last digit, the unit digit, the 0, the ones place, if it is 0, divisible by 10, not to do anything else. If the last digit is 0, that means it is divisible by 10. Divisibility by 5, so last digit must be 0 or 5, nothing else. The last digit must be 0 or 5. If it is like that, it will be divisible by 5, otherwise not at all. Let's move on to some other divisibility test. Divisibility by 11, again this is also a very good concept, very interesting one. A number is divisible by 11 if the difference between the sum of its digits at odd place and even place is either 0 or a number divisible by 11. Say for example, see, this is the number. We have 294354117. Now the question is this divisible by 11? Let's check it out. Do one thing. Odd places 2, 4, 5, 1. Add them. 2, 4, 5, 2, 4, 5, 1. Add them. And 9, 3, 4, 7. 9, 3, 4, 7. Add them. When you add these and these, just subtract them. So 23 minus 12. We got 11. So if the number is divisible by 11, then the whole number is divisible by 11. Just check from the calculator if you want to. Similar like this. What about 25? There's only one thing you know. The last two digit is 0, 0 or divisible by 5. So 0, 0 or divisible by 5. Say for example this number. The last two digit is 75. So 75 is obviously divisible by 5. 25. So this will always be divisible by 25. I make it easier. The last two digits must be 0, 0, 25, 75 and 50. If out of these 4, only these 4, if these come, then the number will be divisible by 5, because 25 ones are 25, 25 twos are 50, 25 threes are 75, 4s are 100. Again repeat the same thing again and again. So any big number, if the last two digits are from these 0, 0, 25, 75 or 50, then the number will be divisible by 25, otherwise not. So in this way, in the book, you will find there are many divisibility tests. You just do one thing, they have with example. So you just do them by yourself and you will see they are very easy. Let's move on to the other concept. What is that? We have modulus of a number. What is modulus of a number? Modulus of a number is always positive. So if it is negative, then put a minus there. So minus minus plus will be there. So this mod is always gives a positive number. That is it. Minus 5 in the mod will give you 5. We call it filter. So all the minuses remain there and the number comes. That's it. So if it is minus 5, it is 5. If it is 5, it is 5. So all the minus numbers are converted to positive numbers with the modulus, right? The greatest integral value of an integer, the greatest integral value of integer x, denoted by x, is defined as greatest integer not exceeding x. Simple. 1.35. So 1.35 means what is the greatest integral number? That is 1, because we will take only the integer part and not the decimal part. Say for example 11 by 4, it can be written as 2, 3 by 4. So greatest integral number is 2, because we just don't want the point part. So leaving all the decimal part, this bracket denotes the greatest integral number. Multiplication by shortcut method. Now see, this is very important. If you are doing maths after a long time, or a maths after a, say for example you are not very good at maths, these shortcut will definitely help you. Multiplication by distributive law. What is distributive law? So if A into B plus C is written, then we know it, AB plus AC. A will be multiplied by B, A will be multiplied by C. Similarly, if it is A, B minus C, then do minus, right? So very important to note. Say for example this one. So it is like 9999, so that is 5 nines are there. 5 nines can be written as 151 with 5 zeros minus 1. So what you will do is, multiplication with this is very easy, because you just need to put all the zeros minus this, so it will be easier for you to calculate. So this is the way you need to do. And the other concept I must tell you, multiplication of a number by 5 raised to power n. Whatever it is 5 raised to power n, put n zeros to the right and multiplicand and divide the number by 2 raised to power n. So this 625 can be written as 5 raised to power 4. 5 raised to power 4 means put 4 zeros and divide it by 2 raised to power 4, that is 16. So we got it very easily, right? So this is the way you do. So in this manner, I have told you the basic concept about this topic. I know the topic was bit bigger, but it was required for the questions. So now when we'll do questions, you will be doing like all those questions very fast. So ab der kis baat ki hai? Chalte hain seedha questions pe. Here we go. We have question number 1 with us. What does it say? What is the sum of first 20 odd natural numbers? 20 odd natural numbers. We have a formula. Just write that formula in your notebook. Then when you want to find the sum of first n odd digit, sum of first n odd digit number, it will be n square. That means n here is 20. So 20 का square करेंगे, we'll get 400. So don't need anything. आपको लिखने की जरूरत नहीं है. 1, then 3, then 5, then 7. You can try it any day. Say for example, first 3 odd numbers. 3 odd number is 3 square, that is 9. And you know it very well, 1, 5, 1, 3, 5. These are the first 3 odd numbers. Add them, 5 and 3, 8 and 1, 9. So directly you can apply the formula. First n odd number, the sum of them will be n square. Let's move on to the next question. Here we go. Question number 5 with us. Let's see what does it say. The sum of the squares of two positive integers is 130. The sum of the squares, once it was written square of the sums and one it is sum of the squares. So say for example, what does it say? It says a square plus b square is equal to 130, where a is one of those positive integer and b is the other positive integer. We have considered, we have let suppose one is a and one is b. So a square plus b square is given 130. Difference of their square, a square minus b square, what is given? 32. So we have given difference of their squares, we have given the sum of their squares. We have two equations, right? What we'll do is just add these two equations. When you add a square plus a square, it becomes 2a square. When you add b square minus b square, it gets cancelled out. When you add these two, we'll get 2, then 3 and 3 is 6, we'll get 1. So we'll get 162. Now it is 2a square, 162. We have a square is equal to 162 divided by 2, right? So when you divide this, now how come this is divided by 2? We have two ideas, like just divide the whole equation by 2. So 2 by 2 is 1 and 162 by 2 is what we are really finding it. Other thing is, anything here from left side, when it goes to the right side, say something is plus here, it goes here by minus. When anything is multiplied, it goes divide. When anything minus here, it goes plus. Anything divide goes multiplication. So when you transform, when you change your state from left side to the right side or right side to the left side, multiplication becomes divide, divide becomes multiplication, plus becomes minus and minus becomes plus. So a square is equal to 162 by 2. Just divide this, we will get 81. So we have got a square is equal to 81. See, if a square is equal to 81, that means a is equal to root 81. What we did? We did just the same thing. On the both side, we just put a root. So a square ka root, a will remain. And root 81 is equal to 9. So a is given as 9, right? We have just found a. Now we come to this. See, we have got a square minus b square is equal to 32, right? So a is given as 9. So 9 ka square minus b square is equal to 32. That we can do. Now do one thing. Let this 9 square remains here. 9 square. This minus b square goes there. It becomes plus b square, right? So we write plus b square. This 32 comes here. It is plus 32. It comes at minus 32. So we'll change the places. We got b square is equal to 9 square, that is 81, minus 32. So we have got b square is equal to, what is that? 1 minus 2, that is 9, 11. So we have got 6 left, 7 left. 7 minus 3 is 4. So b square is equal to 49. Just put the roots. B is equal to 7. So we have b equal to 7. We have a equal to 9. Just add these two. 7 and 9. The answer is 16. Now see if there is any option like 16 in the question. Yes, it is. We have question number 5. The answer is D for Delhi. So let's move on to the next question. Here we go. We have this number. So we need to find out the sum of this. First thing I tell you, if I want to know the sum of first n numbers, say for example, we need to find out 1, 2, 3, 4, 5, 6, 7 till 20. So what we can do? Now this is 91 to 110. One option says 91 plus 92 plus 93 plus 94 plus 95 and 96. Add them all. It will take a lot of time. So why do I need to waste all the time in adding them? We must have some formula. So for sum of first n numbers, we have n into n plus 1 by 2. Whatever the number is. See, if you want to say, for example, want to go for how much is the first 10 numbers? So we have got 10 here, we have got 11 here. So what I'll do is 10 into 11 by 2. So it is like 110 by 2. That will be 55. So if you calculate them all, for sure it will come as 55. So now we have the formula that for first n number we can do just one thing. Just n into n plus 1 by 2. Now what about this one? From 91 it is saying 110. So what you can do? See, sum of 110, 1 to 110 minus sum of 1 to 90. See this. If I write, say for example, 1 to 110, and if I just subtract them 1 to 90, if I add all of them till from starting from 1 till 110 and then subtract 1 from 1 till 90, just remove them. So it will remain like this only. Sum of 110 numbers, as you know, 110 into 111 divide by 2 minus 1 to 90, 90 into 91 divide by 2. Now this we need to calculate. Let's calculate it fast. Now 1 1 1 and 1 1 0, 0 0 0, 1 1 1, 1 1 1. So we have got 0 here, we have got 1 here, we have got 2 here, 2 here and 1 here. So it will be like 1 2 2 1 0 divided by 2, and that is the multiplication of 111 into 110, right? Now what about the next number? 91 into 90. I don't think that will be tough again. So 1, so it is like 0 9, 9 zeros are 0 and 9 nines are 81. So we have got 0 9 1 8. So we have got 8190 divided by 2, right? When you divide this by 2, we have got 12. So 12 when divided by 2 is 6. We have got 2, that is 1 time. Then we have 10, so 0 5. Minus, divide this by 2. 8 is like 4. 1 is not divisible. So 19. 19 is 18. 18 is 9. We got 1. So 5. So 4095. The 6105 minus 4095. Just put it here. 4095. 5 minus 5 is 0. 10 minus 9 is 1. 0 becomes 0. So 0 is 0. And 6 minus 4 is 2. So we got 2010. Now I need to check whether 2010 is there any option like this. Yes, we do have. So in this way you have seen one thing, that this is a previous year examination question. Second thing is, you don't need to add all of them. Just do the basic calculation, sum of 110 numbers, then minus sum of 1 to 90 number will remain is this number only. So we just calculate and we got the answer. Here we move on to the next question, where we have question number 13. Let's see what does it say. It say that what least number must be subtracted from now this 3401. Now we just do one thing, just divide it by 11. So there will be some remainder. That remainder when subtracted from this, the remaining number will surely be divisible by 11. So we do it like 3 times. We have 33 here, right? Now it is 10. So 10 is not working, just 0, 101. Now 99 is divisible, right? So 99 is, remainder is 2. Now this is the remainder. When I remove this 2, we will get, it will be 3399, and this is for sure divisible by 11, 309, right? So in this way, when you need to do such type of question, that least number must be subtracted or added or something, just divide it, get the remainder and do the accordingly, right? Here we move on to the next question. Here we go. Question number 18 for you all. The product of two positive numbers is 11 and 52. So two positive numbers, say for example A into B, it comes out to be 1152. Now if the one number is 2 times the other number, what does it say? If one number is equal to 2 times the other number, then what will the sum of the two number? So what we need to find is A plus B we need to find. But first is given this. So A is equal to 2B. So what I'll do is 2B into B is equal to 1152. Now B into B is B square. So B square is equal to 1152. Now this 2 is multiplied. When it goes to the other side of equal to, it gets divided, right? So what we'll do? Just divide it. 11, when you divide 11 by 2, it's like 10. So 5 times 15. So 14, 7 times 12, 6 times. So B square come up to 576. Now this 576 is square of 24. Just put a root here. So B comes out to be 24. Now see what is given. A is equal to 2B. So A is equal to 2 into 24, right? So 24 into 2 is A is equal to 48. Now we need to find A plus B. Just put 24 here. Just put 48 here. Just add them up. So 8 and 4 is 12. Carries 1. 4 and 2 is 6 and 1 7. So answer will be 72 and it is there. It is also from a previous year question paper. So in this, with this, you need to understand that all the questions come in exam with certain tricks. You need to do one thing. Whatever is written in the number system, just put them in a formula, not formula, we can say, put them in a proper format, that is like equation format. Now solve the equation and you are done. Generally, remember one thing, if there are two equations and there are two unknowns, unknowns means A is unknown, B is unknown, variables. So if there are two equations and two variables, answer will come. You just need to check the equations, right? Let's move on to the next question. Question is 24. What does it say? How many natural numbers less than 1000 are divisible by 5 of 7 but not by 35? So we need to calculate this, right? So what I do is, first I will find how many natural numbers less than 1000 are divisible by 5. Do one thing, just divide this 1000 by 5. So it will come as 200. But in this 200, the 1000 is also included. We need to remove that. So 200 minus 1 that is 1000. So we get 199. So all these 199 numbers from 1 to 999 are divisible by 5. Now what about 7? Let's do that. 1000 divided by 7 and we just want the integer part, right? So what I'll do is 7 ones are 7. Then we have got 3, 30. So we have got 4, 28 is 4. So we get 20. 20 is like 2 times and point we remove it. So we have got 142 numbers in 1000 numbers divisible by 7. So for 5 it is 199. For 7 it is 142. Now let's talk about 35. So let's divide this 1000 by 35. Now you think that, oh, 35 se kaun divide karega? See, we can do it directly, very easily. But do one thing, na? Just do it like 7 times and 200. Is that okay? Because we have divided this by 5. Now 7 by 200. So just divide it. 200 is like 20. 20 is like 14, 2 times. Then we have got 6, remaining 6. So 60. So 60 is like 8 times 56. And there is point. We just want the integral part. So 28. There are 28 numbers which are divisible by 35. Out of these two only, because whichever number will be divisible by 35 will sure be divisible by 5 and 7 both. There is no number which is divisible by 5 and 7 both, right? So what we'll do? Now we will do just one thing. We need to calculate this. So there are 199 numbers which are divisible by 5. Then there are 142 numbers which are divisible by 7. Minus there are 28 numbers which are divisible by 35. So just calculate 2 and 9 is like 1, 11, 4, 4 and 1, 5 and 9 is again 40. So we have got 1, then 1, 1 and 1. We have got 341 minus 28. So 41 minus 20 is 13. So we have got 313. 313 numbers are either divisible by 5 or 7, right? So is there any option like that? Yes, it is. So we have got 313. Here we go. We will move on to the next question. So some of the 3 consecutive odd numbers, say for example, it is like any number x, it is like x plus 2 and x plus 4. This will be like 3 consecutive odd numbers. Whatever x is, let's add them first because we need to find the sum. So x plus x, we have got 3x plus 6. Now 3x plus 6, if you know it, whatever value you put for x, whatever value you put, it will always be divisible by 3 because that will be multiplied by 3, and 6, you know it, it is always divisible by 3. So we have got always divisible by 3 for sure. You add any 3 consecutive odd numbers. So let's move on to the next question. Now you can easily feel like that. See, consider this 768 is equal to A and 232. So consider this 232 as B. You can easily write that A into A into A plus B into B into B divide by A into A minus A into B plus A B into B. B into B, right? That what I did was I just converted 768 as A and the other 232 as B. Now you can see that it is like A cube plus B cube, and here we have A square minus AB plus B square. Now from the formulas, if you remember that A cube plus B cube is equal to A plus B, A square minus AB plus B square. So putting this value here, right, what I get is A plus B, we have got A square minus AB plus B square. So we have here A square minus AB plus B square. So just cancel it out, we'll get A plus B, right? So A plus B, we need to find out just A plus B, that is it. So you remember 768 plus 232, that is A plus B, just add them. 2 and 8 is 0, we get 1. 6 and 4 is 0, we get 1. 7 and 2 and 8, 1, again 0 and 1. So it comes out to be 1000. Now see, अगर इस क्वेश्चन को इतना बड़ा देख के छोड़ देते कि यार कौन मल्टीप्लाई करेगा, बहुत मुश्किल हो जाता, एंड छोटा सा कैलकुलेशन लगाया, सिंपल सा 1000 आंसर आया. We move on to the next question. Here we go. This is from MCA 2005. Let's see what does it say. It says that A plus B plus C is equal to 0. So from this equation, we got A plus B, this C goes there, becomes minus C. We got B plus C and A goes there, becomes minus A, and C plus A, B goes there, becomes minus B. Why did I do that? I just did that because I need to calculate this. So we have A plus B is equal to minus A into B plus C is equal to minus B and minus C. That means, oh, B plus C is equal to minus A plus B is equal to minus C, and C plus A is minus B. Now when we calculate this, it becomes minus ABC. So is there any option like minus ABC? If there were 2 minuses, we could have written AB. But there are 3 minuses, so minus remains there. Here we go to the next question. We have this one. No, this one. Let's see. I think there's something like this line should be here. Generally it is here only because it is plus. There's something that happens here. So when I calculate this 5 plus 8 plus 4, what is that? 5 plus 8, 13. 13 plus 4, 17. So we get 7 here, we put 1 here, right? Now we calculate this thing. 8 plus 4, that is 12. 12 plus 9. 12 plus 9 is 21. So we get 2 here. So that must be 1 here. From this carry 1, I just found one thing, that whatever it is like 10 plus x. If I put that star as x, this is x and this is x. So I know one thing, 1 that is carry, plus 3 plus x plus x is equal to 10 plus x. Why so? Because 10 plus x, this 10 as a 1 goes there and we become here, right? Now what to do? Do just one thing. 4 and 2x. So 2x plus 4 is equal to 10 plus x. So x comes here as minus, 4 goes there as minus. So 2x minus x is equal to 10 minus 4. So 2x minus x is x, 10 minus 4 is 6. So we got x equal to 6. So just put them all and you will find the answer. Is there any option? Yes, we have. Let's move on to the next question. Now this is a question of factorial, right? We know that this is known as n factorial. So 8 factorial. We can write 8 factorial as 8 into 7 into 6 into 5 into 4 into 3 into 1. The 6 into 5 into 4 into 1 will known as 6 factorial. Now 7 into 6 factorial minus 6 factorial. What I did is, I just converted all of them in terms of 6 factorial. 7 into 6 factorial will be 7 factorial. 8 into 7 into 6 factorial will be 8 factorial. Now this considers 6 factorial. 6 factorial is equal to, say for example, x. So we have 8 into 7 x minus 7x minus x, right? So let's calculate this first. We just get x as common, right? So I got x as common. Now we got 8 into 7 minus 7 minus 1, right? So 8 into 7, that is 56 minus 7 minus 1. So 56 minus 8, 48. 48x, that means 48 into 6 factorial. Now this 48, let's see what is given in the answer. So 48 can be written as 6 into 8, 6 into 8. So 48 is 6 into 8, 6 factorial. The answer is C. So let's move on to the next question. Here we go. We have the units digits. It is asked that what is the units digit of 13 raised to power 2003. So 13 raised to power 2003. This can be written as 13 raised to power 2003 into 3 raised to power 3. That can be done because 2003 can be written as 2000 plus 3. So anything a raised to power plus is multiplied again. So now calculate this 2000. So 2000 can be written as 500 into 4, right? Now 13 raised to power 4. 13 raised to power 4 is the unit digits of 13 raised to power 4. So 3 into 3, 9. 9 into 3, 27. 27 into 3, 1. So it comes 1. 13 raised to power 4. The unit digit comes at 1. So what we can do is, whatever the value will come as 1 and raised to power 500, it will only be 1. So this will always be 1. Now 13 raised to power 3. So just calculate 3 into 3, 9. So 9 into 3 is 27. So we have got unit digit as 7. So 7 multiplied by 7 is always 7. So in this way you can do it easily. And in this way I suppose you can do all the remaining questions of this section. The more you do, the more confidence you get. So do all the remaining questions and I assure you that you will rock in the exam. So if you want to rock in the exam, do all the questions with your hand on notebook so that you get confidence, right? बहुत सारे questions हैं, questions आपको करने हैं. See, this is a starting of a series, a huge big series. You do all the questions in the coming chapters as well. One thing you need to know, I want just one thing. What we as Shant publication just want one thing, share to the maximum. You have a huge network of students, friends. You do one thing, just share this video to all of your friends. Just subscribe to the channel and press the bell icon so that whenever a new video solution comes, you get the new update, latest update. So do these things. I really appreciate, and that I will really appreciate. So bye for now and we will see you in the next chapter. Thank you.